All right, last example for today. Example 4 says, write the first 6 terms of the geometric sequence whose first term is -3 and whose constant ratio is 4. So, well, they already gave us one term out of the 6 that we need to find. So let's go ahead and list that as -3 is our first term here. And then the constant ratio is the same thing as a constant multiplier, so we just take 4 times our term. So -3 times 4 is -12. There's our second term. Then we take -12 times 4, and that gives us our next term, which is -48. And then we take -48 times our constant ratio, which is 4. So -48 times 4 is -192. So that's 1, 2, 3, 4 terms. So the next term is -192 times 4, which is -768. And we need one more, so we take -768 times 4, and we get -3,072. So 3,072. And those are our first 6 terms. Okay, now give an explicit formula for the sequence. Remember, explicit formula is of the form G of n. And I just like to write these out every time so I get the formula drilled into my head. Equals G of 1 times our constant ratio of whatever that is, and then to the n minus 1 power. And then remember, we're going to have that 4 integers, blah, blah, blah stuff. I'm not going to bother writing it until I actually get my formula here, because that stuff's always the same. So G of n stays as G of n. So G of n equals, and then G of 1, well, that it stands for our first term here. We know our first term was -3, so we put -3 right here. So -3, and then we can fill in our R here, because our R is our constant ratio, and that was 4. So remember, those always go in parentheses. Please do not omit the parentheses, you need them. So to the 4 times 4 to the n minus 1 power, and again, we want to keep n generic, so we leave it as n, and then 1 is just 1, so we just have n minus 1. So there's our formula here, and we of course need to add the words 4 integers, and I'm just going to abbreviate INT, and then n is greater than, for the explicit formulas, n has to be bigger than 1. So we're allowed to start out at term 1 here. Okay, so there is our explicit formula for this sequence, and that's all they asked for in part B. So we have our first 6 terms, which is what they asked for in A. They wanted your explicit formula, which is what they asked for in part B. Now let's see if there's part C, which there is. Give a recursive formula for this sequence. So now if you remember, recursive formulas take the form with braces, then you have G sub 1 equals whatever that is, so you put a number here, and then G sub n equals, now let's go back because this one was from all the way in the beginning. Here it is. G sub n equals R times G sub n minus 1, and then we have all these integers. Now notice this is a 2 here, and I'll explain why in a second. So R times G sub n minus 1. Whoop, too far. Okay, so R, and then times G sub n minus 1, and then you have your comma, 4 integers, blah, blah, blah. Okay, so let's set this up. G sub 1 was our first term. Now if you don't remember, we can always go back a slide. So G sub 1, our first term was -3, so we just put a -3 right here. -3. And then G sub n just stays as G sub n equals R, that's an R, I promise, not an N, which is our constant ratio, which is 4, so we put a 4 right there. 4 times G sub n minus 1. Now that just stands for our previous term, remember? So that's our previous term times 4. Okay? And then we need comma, 4 integers, greater than or equal to, so n is greater than or equal to 2 this time, not 1. We could have 1 before. We cannot have 1 now because, well, a couple reasons. We're starting at g sub 1, so why would we need to do 1? Because we already have 1, so we start at 2. And the other reason is that if we put 1 in here, we'd have g sub 1 equals 4 times g sub 1 minus 1, which would be g sub 0, and we don't have the g sub 0th term. So we have to start at 2 here because we already have the first term. Back here with our explicit formula, we started at 1 because we didn't have the first term yet. We start out at g sub n, so we have to find the first term. That's why we start here at 1. And that is it for recursive formulas, excuse me, geometric formulas using recursive and explicit formula writing. So hopefully you'll be prepared to do your worksheets in class tomorrow. Au revoir.